Abstraction. Introduction. What is abstraction? Abstraction is the process of hiding the implementation details and shows only the important details to the user. Information hiding is the purposeful omission of details in the development of abstract representation. In this figure, we have different types of vehicles which have different color, shape, engine type and purpose etc. that makes them different. But they have some common properties and behavior among them. That is, they all have tires, engine, steering, gear etc. They are used for the traveling and can be operated in a common way. Abstract concept is vehicle can be the general idea of a car or a truck. It retains only the general vehicle attributes and behavior, omit the other characteristics of a particular vehicle. Layers of abstraction. There are 6 layers of abstraction. At the highest level of abstraction, we view a program as a community of interacting objects, packages and namespaces. The next level of abstraction is found in some, but not all, object-oriented languages. A package unit or namespace allows a programmer to surround a collection of objects, that is a small community in itself, with a layer and control visibility from outside the module. Clients and servers. The next level of abstraction considers the relationship between two individual objects. Typically, one is providing a service and the other is using the service. Description of services. We can next examine the server providing a service independent of the client. We define the nature of the services that are offered, but not how those services are realized. We can simply understand this by given billboard advertisement, which describes the services provided by stacked data structure. Interfaces. Interfaces are one way to describe services at this level of abstraction. Here is a simple program to declare the interface animal. The two methods eat and run are declared inside the interface. For example, interface animal open bracket public void eat public void run bracket closed. An implementation of an interface. Next, we look at the services provided, but from the implementation side. The program shown here explains the implementation of an interface. Public class mammal implements animal. Animal is interface given here. Open bracket public void eat, that is method, then bracket close. Concern here is with the high level approach to provide the designated service. Next one, a method in isolation. Finally, we consider the implementation of each method in isolation. Public class mammal implements animal open bracket public void run open bracket system.out.println mammal runs bracket closed. Every level is important and often you move quickly back and forth between levels. Other forms of abstraction. Abstraction is used to help understand a complex system. Abstraction idea is divided into distinct forms. In this example, we show some different forms of a motor vehicle such as specialization, multiple views, and division into parts. Division into parts. Encapsulation and interchangeability. Interface and implementation. The service view. Composition, division into specialization and patterns. Division into parts as a abstraction. Division into parts takes a complex system and divides into component parts which can then be considered in isolation. Characterized by sentences that have the words has a. A car has an engine and has a transmission. A bicycle has a wheel. A window has a menu bar. Allows us to drop down a level of complexity when we consider the component in isolation. Encapsulation and interchangeability. Encapsulation allows the programmer to group data and provide a common interface and to hide irrelevant details from the user. It allows two objects differing in internal representation but having the common interface interchangeably usable, that is called interchangeability. For example, a car can have different types of engine and one transmission. Interface and implementation. An interface describes what a system is designed to do. It says nothing about how the assigned task is being performed. To work, an interface is matched with the implementation that completes the abstraction. A key step along the path to developing complex computer systems will be the division of a task into component parts. Each component will have two phases, the interface that it shows to the outside world and an implementation that it uses to fulfill the requirements of the interface. Makes it easier to understand a design at a high level. Makes possible the interchangeability of software components. The service view. Each member of the community of the florist example is providing a service that is used by other members of the group. Another way to think of an interface is as a way of describing the service that an object provides. The interface is a contract for the service. That is, if the interface is upheld, then the service will be provided as described. Composition. Composition is one example, a form of has-a relationship. Heart is a part of a person. The heart does not exist without the person. This is an example of composition. It is characterized by the following: primitive forms, rules for combining old values to create new values, the idea that new values can also be subject to further combination. Examples include regular expressions, type systems, windows, and lots of other complex systems. Division into specialization is a abstraction. Is-a abstraction takes a complex system and views it as an instance of a more general abstraction, characterized by sentences that have the words is equal to a. A car is a wheeled vehicle which is a means of transportation. A bicycle is a wheeled vehicle. A pack horse is a means of transportation. Allows us to categorize artifact and information and make it applicable to many different situations. Patterns. Patterns provide a common way to communicate, document, and reuse abstractions. Patterns depicts the useful relationship between objects, and it helps to find out the solution of new problems. Example: pattern proxy. A simple example will explain this idea of a pattern. Imagine one is developing an application that will operate over a network. It means that the part of the application will run on one computer and another part will run on another computer linked by a network connection. Creating the actual connection between two computers and transmitting information along this connection are details that are perhaps not relevant to a large portion of the application. One way to structure this relationship is to use a type of pattern termed a proxy. The proxy is an intermediary that hides a network connection. Objects can interact with the proxy and not be aware that any type of network connection is involved at all. The proxy bundles the request as a package, transmits the package over the network, receives the response, unpackages the response, and hands it back to the client when it receives a request for data or action. The client is completely unaware of the details of the network protocol in this fashion.